Okay, so part 2. So how can I actually use my inverse? So finding inverse sine values. Okay, so let's find the y. So find the y in each equation and in radians. Okay, so here's our first one. So y is equal to arc sine of 1/2. Okay, so essentially inverse just means that we're switching where our numbers and letters are, right? And so really what we're trying to figure out is the sine of what value is going to give me a 1/2. Okay, so we have to think about this logically, right? So where is sine positive? Sine is positive in the first quadrant. So it's positive in the first quadrant where y would be pi over 6, right? And it's also positive in the second quadrant, right? Where it would be 5 pi over 6. But if we remember from our chart, we only want to deal with domain between negative pi over 2 and pi over 2, right? So when I look at this problem, 5 pi over 6, that's outside my restricted domain. So outside the restricted domain. So that means that this is our only answer. And again, sine, we're only dealing with our first quadrant and our fourth quadrant. So that means where is it going to be positive? It's only going to be positive in that first quadrant. All right, let's take a look at another one. What happens if I write like this? Y is equal to the inverse of sine of -1. So again, what this is asking us, do a different color this time. So we are saying if I flip these, sine of what will give me -1. And this time there is only one answer. So again, it's going to be that guy right there. But we only want to take it from negative pi over 2 to pi over 2. So we don't want this to be that 3 pi over 2. So this time our answer is y is equal to negative pi over 2. Let's try one more. What happens if I have this one? So y is equal to arc sine of, let me erase that. So arc sine of -2. So again, what this means, do a different color, we're saying sine of something, right, is going to be -2. Now, -2 is outside of our original range. And again, it's not in our domain when I kind of flip it around. So that means that this is a D and E. So it doesn't exist. There is no answer that you can plug in that will give you a -2 as an output. Okay, let's try a few more. So, so this time, let's find the inverse of cosine. Okay, so here's our first one for cosine. So y is equal to arc cosine of 1. So again, it's important to remember that cosine, we are dealing with the first and the second quadrant. So again, this is like saying cosine of what is going to give me a 1. And again, this will be in radians. Okay, and the only number that will give you 1 is actually 0. So y is equal to 0. Let's try another one. So y is equal to the inverse of cosine of -√2 over 2. Again, that's like saying cosine of something. That would be at -√2 over 2. Again, where is it going to be negative? It's going to be negative in the second quadrant. Again, we want it to be in radians. So 3 pi over 4. All right. Let's try one more. So y is equal to the cosine of 1/2. So this will become the cosine of y is equal to 1/2. Where is cosine positive? Again, just in quadrant 1. So cosine of 1/2 will be pi over 3. And that's it. Those are your answers. Again, we'll never, ever take it into our third quadrant. Let's do tangent. So let's do our own tangents. So finding tangent, inverse values in radians. All right, so remember tangent is similar to sine. It is going to be from those 2 points. So pi over 2 and negative pi over 2. So let's try our first one. So y is equal to the inverse of tangent of 1. Again, this is like saying tan of something will give you the number 1. And that something is your pi over 4. Number 2, y is equal to, let's say, arc tan of root 3 over 3, but let's make it negative, right? So again, this is like saying tan of something of negative root 3 over 3. And again, tangent's always the tricky one, right? So when we're thinking about our tangent, right, we have 2 choices that we can make. We can either use the 1/2 comma the root 3 over 3, or we could say root 3 over 2 and then the 1/2. Okay. To get the root 3 over 3, it's going to be this guy right here, 1/2 divided by root 3 over 2, which is the same thing as 2 over root 3, 1 over root 3, which ultimately gives you root 3 over root 3. So again, it's important to know which one this coordinate is. If you are in the 4th quadrant, that means that your y was negative. So that's why that is going to turn negative. And then root 3 over 2 and then the 1/2, the y value is going to be your pi over 6, but it's your negative pi over 6. So again, if you want to figure out, if you want to keep using some of our strategies from our previous chapters where we are using the negative angle identities, right? If we pull out, so if we know that the negative angle of something, right, that's the same thing as saying the tangent and the negative number, right? So we can still use that idea. All right, let's try a few more now. Let's find it with the degrees. So find the degree measurement of theta. All right, so let's try our first one. So I'm not going to be specific of sine, cosine, tangent. I'll kind of do all of them, or maybe other ones. So here's our first one. Theta is equal to arc cosecant of -2. So for this one, this would be like saying cosecant of theta is equal to -2, right? I know, again, from previous chapters, I know that the cosecant and sine are similar to each other. So I know that this function, which means that if -2 is equal to 1 over sine of theta, right, that means that the sine of theta really is the reciprocal, and it's 1/2. That helps me trying to figure out which quadrants I'm in. Again, this is cosecant, so technically there's an open circle right there. -1/2 right here. So it'll be -30 degrees. So again, if you don't know your unit circle, like the back of your hand at this point, it's going to make this section challenging. All right, let's try another one. So number 2, let's do another one that we have not done. How about the arc secant? 1. So for the arc secant, that's like saying the secant of theta is equal to 1. If I flip this and make it become the reciprocal, I'm going to flip that fraction, and it's the same thing as 1, right? So again, I'm looking from here to here. Technically, it was arc of the secant, so there will be an open circle here, but we're dealing with it at that point right there. So that means that theta is 0 degrees. Don't forget the degree symbol when we are solving this. And let's try one more. So let's go theta is equal to the inverse of sine of negative root 2 over 2. So again, that's like saying sine of theta is equal to negative root 2 over 2. Again, very similar to that drawing. So the only answer that we can have would be a negative 45 degrees. Because a positive 45 degrees, we have the positive radical of 2 instead of the negative radical of 2. So again, you can go ahead and look at your unit circle, kind of practice, pick some points, and see how we do. When we come back, we're going to talk about how we can use our right triangles to help find our inverses.